Okay, we're at the module 7 of ENSA, which is WAN Concepts. Okay, so we're going to look at the purpose of WANs. We're going to look at how they operate. We'll look at traditional WAN connectivity. We'll look at modern WAN connectivity, and we'll look at internet-based connectivity. So the purpose of WANs. So a WAN, or wide area network, is a telecommunications network that spans over a relatively large geographical area and is required to connect beyond the boundary of the LAN. So, of course, a WAN is basically, its purpose is to join LANs together. And so, remote LANs together. All right, so LANs provide networking services within a small geographical area. WANs provide networking services over a large geographical area. LANs are used to interconnect local computers, peripherals, and other devices. WANs are used to interconnect remote users, networks, and sites. A LAN is owned and managed by an organization or home user. WANs are owned and managed by internet service, telephone, cable, or satellite providers. Other than the network infrastructure cost, there is no fee to use a LAN. WANs, of course, because you're using the services of the above ones, you need to pay a monthly fee typically. LANs provide high bandwidth speeds using wired Ethernet and Wi-Fi services. WAN providers offer low to high bandwidth speeds over long distances. Of course, the higher the speed, the higher the cost typically. Okay, so there are private and public WANs. So private WAN is a connection that is dedicated to a single customer, and so you get guaranteed service level, consistent bandwidth, and security. While a public WAN connection is typically provided by an ISP, or telecommunications service provider using the internet. In this case, the service levels and bandwidth may vary, and the shared connections do not guarantee security. WANs are implemented in the following logical topology designs. So point-to-point topology, so that's two WANs joined together by one WAN link, and so it's point-to-point. Hub and spoke is basically main office and a link to every branch office. There's dual home topology, there's full mesh topology, and there's partial mesh topology. And so large networks usually deploy a combination of these topologies. So point-to-point employs a point-to-point circuit between two endpoints and it involves a layer 2 transport service through the service provider network. The point-to-point connection is transparent to the customer network. It can become expensive if many point-to-point connections are required. And so it's not a good LAN diagram unless there's a cloud. So of course that cloud means it's provided by the your provider, and what actually happens inside the network is often not visible, hence the cloud. All right. So hub and spoke, as I said, is where you have a main office and then all of your branch offices connect together. And so enables a single interface on the hub router to be shared by all spoke circuits. Spoke routers can be interconnected through the hub router using virtual circuits and routed sub-interfaces. Spoke routers can only communicate with each other through the hub router. Note that the hub router represents a single point of failure. If it fails, inter-spoke communications also fails. Hence the dual homed. And so it offers enhanced network redundancy, load balancing, distributed computing and processing, the ability to implement backup service provider connections. More expensive to implement than single home topologies. This is because they require additional networking hardware, such as additional routers and switches. More difficult to implement because they require additional and more complex configurations. But of course, as you can see, there's two virtual circuits typically on each site, and so if one goes down, the other one will work. So that's, well, should work. All right, so a fully meshed topology uses virtual circuits to connect all sites, and so the most fault tolerant topology. So basically a full mesh means that there's a direct connection between each site and every other site. So you'll see here that there's 4 sites in this diagram, and so each site actually has 3 connections coming out of it. And so when you add another site, you will need 4 new connections for that extra site. And so the number of links basically grows exponentially as you grow sites. So it's very fault tolerant, but it is but it is, of course, the most expensive. And so partial mesh connects many but not all sites. Well, I'm not so sure about that description. It has redundant links, but every site does not directly connect to every other site. And so as you can see here, site D only has one link. And so I'm assuming site A must be head office. And so, of course, if the link between site C and A fails, it can actually go via site B and you'll have some redundancy. So, of course, this is a very small diagram, but basically, you know, you could actually have some redundancies for each site, but obviously site D is not particularly important to them. Okay, so carrier connections. Another aspect of WAN design is how an organisation connects to the internet. An organisation usually signs a service level agreement with the service provider. The SLA outlines the expected services relating to the reliability and availability of that connection. The service provider may or may not be the actual carrier. A carrier owns and maintains physical connection and equipment between the provider and the customer. Typically, an organisation would choose either a single carrier or a dual carrier WAN connection. So a single carrier connection is when the organisation connects to only one service provider, and SLA is negotiated between the organisation and the service provider. A dual carrier connection provides redundancy and increases network availability. The organisation negotiates separate SLAs with two different service providers. So again, if one service provider has problems, you've got some redundancy in service providers as well. And so there's some upside there as well. Okay. So evolving networks. Network requirements of a company can change dramatically as the company grows over time. A network must meet the day-to-day operational needs of business, and it must be able to adapt and grow as a company changes. Network designers and administrators meet these challenges by carefully choosing network technologies, protocols, and service providers. Networks can be optimized by using a variety of network design techniques and architectures. To illustrate differences between network size, we will use a fictitious company called Span Engineering as it grows from a small local business into a global enterprise. So, at the start, Span is a small fictitious company started with a few employees in a small office. Uses a single LAN connected to a wireless router for sharing data and peripherals. Connection to the internet is through a common broadband service called DSL, or Digital Subscriber Line. IT support is contracted from the DSL provider. Okay, so now the company grows a bit after a few years, and so they need several floors of a much larger building, and so they call it a campus area network. And so a firewall secures internet access to corporate users. In-house IT staff support and maintain that network. Okay, we're growing again. We've got multiple branches. So a few years later, the company expanded and added a branch site in the city and remote and regional sites in other cities. The company now required a metropolitan area network to interconnect the sites within the city. To connect to the central office, branch offices in nearby cities use private dedicated lines through their local service provider. And now it's gotten very, very big. So after 20 years and has grown to thousands of employees distributed in offices worldwide, site-to-site remote access virtual private networks, or VPNs, enable the company to use the internet to connect easily and securely with employees and facilities around the world. Okay, so how do WANs operate? So modern WAN standards are defined and managed by a number of recognisable authorities, including the following. So TIA, EIA, which is the Telecommunications Industry Association, and the Electronic Engine Industries Alliance. There's the ISO, International Standards Organisation, and then there's the IEEE, Institute of Electrical and Electronic Engineers. So most WAN standards focus on the physical and data link layers, and so some of the protocols used can be SDH, or synchronous digital hierarchy. There's synchronous optical network, or SONET, or there's dense wavelength division multiplexing, which is another way of using fiber. Okay, so that's the layer 1 protocols. Layer 2 can use broadband, wireless, Ethernet, WAN, or Metro Ethernet, multi-protocol label switching, point-to-point protocol, HDLC, that's a bit older. Frame relay is again not quite as old, but it's disappearing, and ATM again is disappearing basically. So yeah, we'll talk about those a bit later. There are specific terms used to describe WAN connections between the subscriber, customer, and the WAN service provider. So there's a DTE, which is data terminal equipment. So it connects the subscriber's LAN to the WAN communication device. And so then there's a DCE, device used to communicate with the provider. And so that's, at least in Australia and Europe, that's normally supplied by the telco. In America and Japan, it's normally supplied by the customer. And so then there's customer premises equipment, is a DT and DCE devices located in the enterprise edge. Point of presence, the point where the subscriber connects to the service provider network. And the demarcation point is the physical location in a building or complex that officially separates the customer premises equipment from the service provider equipment. And so it's that demarcation line and the CPE that is different between the Americans and most of the rest of the world. And so normally the DCE in Australia is actually part of the company. The supplier, while it's normally the DTE is the router, is the company's premises. But anyway, so the demarcation line, of course, is the border between the two. Now, some other common terminology is local loop, which is basically the link, or last mile, which is the link between their exchange and your premises. The central office is the local service provider facility. So again, it's the exchange or whatever you want to call it. The toll network includes backhaul, long haul, or digital fiber optic communications line switches, routers, and other equipment inside the WAN provider network. Backhaul network connects multiple access nodes to the service provider network. And the backbone network is large, high-capacity networks used for interconnect service provider networks and to create a redundant network. Okay. So there are many types of devices that are specific to WAN environments. So there's a voice band modem, so the old dial-up modem, and so they're very much legacy devices now. DSL or cable modems, and so collectively known as broadband modems. These high-speed digital modems connect to the DTE router using an Ethernet interface. CSU DSU, which is a digital lease line, requires a CSU and a DSU. It connects a digital device to a digital line. Optical converter can connect fiber optic media to copper media and convert optical signals to electronic pulses. Wireless router access point, devices are used to wirelessly connect to a WAN provider, or you can have a WAN core devices, which are multiple high-speed routers and layer 3 switches. Okay, so serial communication. So almost all network communications occur in a serial communication delivery. Serial communication transmits bits sequentially over a single channel. So so one connection and the ones and zeros follow one another. In contrast, parallel communication simultaneously transmits several bits using multiple wires. And that works nicely until the cable length increases. The synchronization timing between multiple channels becomes more sensitive to distance. For this reason, parallel communication is limited to very short distances. Also, the magnetic fields from one line can actually upset the other and so on. So the old parallel cables for printers had a very limited distance that you could run them. Okay, so circuit switch communication. And so the network establishes a dedicated circuit or channel between endpoints before the users can communicate. So this is like your traditional telephone. So establishes a dedicated virtual connection through the service provider network before communication can start. All communications use the same path. The two most common types of circuit switch WAN technologies are the public switch telephone network. So that's the old, or what's sometimes called POTS, plain old telephone system. And then there's another legacy process that was called ISDN, was actually supposed to replace POTS, but never really did because it was never really affordable. And so these actually reserve the resources through the network to get from one site to the next. So of course that's the dialing weight when you use the old POTS telephones. So packet switch networks is most commonly implemented using packet switched communication. So segments traffic data into packets that are routed over a shared network, much less expensive and more flexible than circuit switching. Common types of packet switched WAN technologies are Ethernet WAN, Mpls or modem protocol label switching, frame relay, and asynchronous transfer mode. And so basically, you're always connected, and basically you have a virtual circuit or something like that that actually helps navigate your packets through the cloud to your destination. Okay, so some of the connections. So service provider networks use fiber optic infrastructures to transport user data between destinations. Fiber optic cable is far superior to copper cable for long distance transmissions due to its much lower attenuation and susceptibility to interference. The two optical fiber OSI layer 1 standards available are SDH, which is synchronous digital hierarchy. So it's a global standard for transporting data over fiber optic cable. Or this SONET, or synchronous optical networking, is the North American standard that provides the same service as SDH. So they define how to transfer multiple data, voice, and communications over optical fiber using lasers or LEDs over great distances. There is also dense wavelengths division multiplexing. So it's a newer technology that increases the data carrying capability of SDH and SONET by simultaneously sending multiple streams of data using different wavelengths of light. So basically different colors. And so multiplexing means you've got more than one signal going through the cable at the same time. Okay, traditional WAN connectivity. So to understand the WANs of today, it helps to know where they started. When LANs appeared in the 1980s, organizations began to see the need to interconnect with other locations. To do so, they needed their networks to connect to the local loop of a service provider. This was accomplished by using dedicated lines or using switched services from a service provider. And so you had the dedicated option. So a lease line was the most common one. And so T1, E1, T3, E3 are sort of levels of service, normally related to speed. And so when it comes to switched, you either had circuit switched or packet switched, which we've already looked at. Circuit switched, of course, means you need to make the connection through the network before any data can move, while frame relay or ATM or packet switched network can basically be up 24/7. Now, common WAN terminology. So point-to-point lines could be leased from a service provider and were called lease lines. The term refers to the fact that the organization pays a monthly fee to a service provider to use the line. So lease lines are available in different fixed capacities and generally priced based on the bandwidth required and the distance between the two connected points. There are two systems used to define digital capacity over a copper media serial link, and so the T or E. T is again North American, E is European. So T1 is 1.544 megabits per second, while T3 is 43.7 megabits per second. Now Australia uses the E standard, so European, and so E1 is 2 megabits per second, and E3 is 34.3 megabits per second. Okay, so the table summarizes the advantages and disadvantages of lease lines. They're simple, so point-to-point communications link require minimal expertise to install and maintain. Quality, so point-to-point communication links offer high-quality service if they have adequate bandwidth. Availability, constantly available, is essential for some applications such as e-commerce. Point-to-point communications links provide permanent dedicated capacity which is required for VoIP or video over IP. Disadvantages are cost. So point-to-point links are generally the most expensive type of WAN access. The cost of lease lines solution can become significant when they are used to connect many sites over increasing distances. Limited flexibility. WAN traffic is often variable and lease lines have fixed capacity, so the bandwidth of the line seldom matches the need exactly. Okay, so when it comes to circuit switch connections, provided by the Public Service Telephone Network, or PSTN. The local loop connecting the CPE to the CO is copper media. There are two traditional circuit switched options. So PSTN is a dial-up WAN using PSTN as its WAN connection. Traditional local loops can transport binary computer data through voice telephone network using a voice band modem. The physical characteristics of the local loop and its connection to the PSTN limit the rate of signal to less than 56 kilobits per second, which is terrible. ISDN is a circuit switch technology that enables the PSTN local loop to carry digital signals. This provided higher capacity switch connections than dial-up. ISDN provides for data rates from 45 kilobits per second to 2 megabits per second. So, yeah, typically better. And also you have the option of more than one connection at the same time with ISDN, but it was always more expensive and yeah, wasn't well adopted. Okay, so packet switched options. So packet switch segments data into packets that are routed over a shared medium, allows many pairs of nodes to communicate over the same channel. There are two different legacy circuit switched options. And so frame relay is a simple layer 2 non-broadcast multi-access or NBMA WAN technology that was used to interconnect enterprise LANs. Frame relay creates permanent virtual circuits which are uniquely identified by a data link connection identifier or DELC. So they were very good for companies. You could actually have one link on every site, but you could have multiple of these virtual circuits from the head office to each of your other sites. And so it was a very flexible system, but the bandwidth available was always variable. And yeah, and so of course we use a lot more bandwidth these days. So ATM, or asynchronous transfer mode, is capable of transferring voice, video, and data through private and public networks. ATM is built on a cell-based architecture rather than frame-based. ATM cells are always a fixed length of 53 bytes. Now, ATM was actually designed by telephone companies, and it's very good for doing voice data. Problem is, it's not all that great at doing data because 53 byte cells is not very big. You know, most of our frame sizes are around 1500, and so you actually have to chop the cells, the frames into cells before you can actually transfer them, and it just adds a lot of extra overhead. So frame relay and ATM have been largely replaced by faster Metro Ethernet and Internet-based solutions. Okay, so modern WAN connectivity. Modern WANs have more connectivity options than traditional WANs. Enterprises now require faster and more flexible WAN connectivity options. Traditional WAN connectivity options have rapidly declined in use because they are either no longer available, too expensive, or have limited bandwidth. So the figure displays local loop connections most likely encountered today. So you've got coax cable, telephone lines, optical fiber, cellular, wireless, or satellite. Now, new technologies are continually emerging. The figure summarizes modern WAN connectivity options. So dedicated broadband. So fiber can be installed independently of an organization to connect remote locations directly together. Dark fiber can be leased or purchased from a supplier. Then they can have packet switched. So you can have Metro Ethernet replacing many traditional WAN options, or Mpls, which enables sites to connect to the provider regardless of access technologies. And then there's internet-based broadbands. Organizations are now commonly using global internet infrastructure for WAN connectivity. And so we've gone from dedicated and switched to internet-based as well. So Ethernet WANs. Service providers now offer Ethernet WAN service using fiber optic cabling, and you can go by many names, including Metropolitan Ethernet, Ethernet over Mpls, by virtual private LAN service. There are several benefits over an Ethernet WAN: reduces expenses and administration, easy integration with existing networks, enhances business productivity. So they've gained popularity and are now commonly being used to replace the traditional serial point-to-point frame relay and ATM links. And so yes, it does work very nicely. All right, so Mpls, or multi-protocol label switching, is a high-performance service provider WAN routing technology to interconnect clients without regard to access method or payload. So it supports a variety of client access methods, be that Ethernet, DSL, cable, frame relay, and it can encapsulate all types of protocols, including IPv4 and IPv6. An Mpls router can be a customer edge router, a service provider router, or an internal provider router. So MPLS routers are label switched routers. They attach labels to packets that are then used by other MPLS routers to forward the traffic. It also provides services for quality of service, traffic engineering, redundancy, and VPNs. Okay, internet-based connectivity. And so we have both wired and wireless options, of course. So internet-based broadband connectivity is an alternative to using dedicated WAN options. And so with the wired options, you can use permanent cabling, be that copper or fiber, to provide consistent bandwidth and reduce error rates and latency. So DSL, or digital subscriber line, and of course the X here means that there's several different standards depending on your needs. There are cable connections, so that's your pay TV basically, so your coaxial cable, and then optical fiber as well, of course, are options. Now when it comes to wireless, wireless options are less expensive to implement compared to other WAN connectivity options because they use radio waves instead of wired media. Examples are cellular like 3G, 4G, 5G, or satellite internet services. Wireless signals can be negatively affected by factors such as distance from radio towers, interference from other sources, and weather. So municipal Wi-Fi, that would be a council supplying Wi-Fi to an area. Cellular, of course, is your telephone, your mobile telephone network. Satellite internet, of course, is connecting to the satellite in space, and WiMAX is sort of like fixed wireless. And so you have an antenna on your roof and someone else has an antenna and relatively short distance away. Okay, so DSL is a high-speed, always-on connection technology that uses existing twisted pair telephone lines to provide IP services to users. DSL characterizes either asymmetrical or symmetric, and also ADSL or SDSL. So ADSL is more for your normal consumers because you have more download bandwidth than you have upload. SDSL means it's symmetrical, so you have the same up as down. DSL transfer rates are dependent on the actual length of the local loop and the type and condition of the cabling. So the longer the cable, the slower it's going to go. And so basically you have an area, 4 kilohertz put aside for the old POTS network. And then this is ADSL, of course. So you've got this much upload frequency and this much download frequency, or actually more. It's not to scale. And so, of course, SDSL would be chopped in half, basically. Okay, so service providers deploy DSL connections in the local loop. The connection is set up between the DSL modem and a DSL access multiplier, or DSLAM. And the DSL modem converts the Ethernet signals from a teleworker device to a DSL signal, which is transmitted to a DSL or DSLAM at the provider location. The DSLAM is located in the central office of the provider and concentrates connections from multiple DSL subscribers. DSL is not a shared medium. Each user has a separate direct connection to the DSLAM. Adding users does not impede performance for other users. That's what it means. All right, so DSL and TPP. ISPs use TPP as a layer 2 protocol for broadband DSL connections. And so the major reason is that it's got authentication built in. That's why they do it. So TPP can also assign an IPv4 address, and it also provides link quality management. And so you'll often get TPPoE as your connection for your DSL router. And so TPPoE client software communicates with the DSL modem using TPPoE, and the modem communicates with ISP using TPP. The router is the TPPoE client and obtains its configuration from the provider. Okay, so cable. So cable is a high-speed, always-on connection technology that uses coax cable from the cable company to provide IP services to users. So data over cable service interface spec, or DOCSIS, is the international standard for adding high bandwidth data to an existing cable system. So the optical node converts RF signals to light pulses over fiber optic cable. The fiber media enables the signals to travel long distances to provide a head end where the cable modem termination service is located. The head end contains the databases needed to provide internet access, while CMTS is responsible for communicating with the cable modems. And so all the local subscribers share the same cable bandwidth. As more users join the service, available bandwidth may drop below the expected rate. So you can see that there's, from their head end office, there's optical fiber, and then from there you have a coax line. And so it's the coax that runs down the street, and that's what you share. So the shorter the coax run, the less people you need to share the bandwidth with. So optical fiber, many municipalities, cities and providers install fiber optic cable to the user location. This is commonly referred to as fiber to the X, so be that home or whatever it might be. So fiber to the home, of course, is to individual residences. Fiber to the building means it's, you know, an apartment block or something like that. Or fiber to the node or neighborhood is optical fiber cabling reaches an optical node that converts optical signals to a format acceptable for the twisted pair. So that's what a lot of us have got here in Australia. FTTX can deliver the highest bandwidth of all broadband options. Of course, FTTH is what most people want. All right, so wireless for internet-based broadband. So municipal Wi-Fi basically is available in many cities, providing high-speed internet access for free or for substantially less than the price of other broadband services. So there is Adelaide Free, not that I've used it in a long time. Cellular, increasingly used to connect devices to the internet using radio waves. So to communicate through a nearby mobile phone tower. So 3, 4 and 5G, I think 3G is going to be gone soon. Or there's long-term evolution or LTE. Satellite internet, typically used by rural users or in remote locations where cable and DSL are not available. Router connects to a satellite dish, which is pointed at a service provider satellite in geosynchronous orbit. Trees and heavy rains can impact the satellite signal, of course. Also, that signal is traveling all the way out to space and then all the way back again. So there's a lot of latency with satellite. WiMAX is basically as it says, it's a microwave access. Is described in IEEE standard 802.16, provides high-speed broadband with wireless access and provides broad coverage like a cell phone network rather than through small Wi-Fi hotspots. I actually still have the antenna on my roof, and that did work very nicely. Okay, so VPN, or virtual private network, can be used to address security concerns incurred when a remote office worker uses broadband services to access the corporate WAN over the internet. A VPN is an encrypted connection between private networks over a public network. VPN tunnels are routed through the internet from the private network of the company to the remote site or employee host. So there are benefits for this. And so the major one is cost savings, eliminates expensive dedicated WAN links and modem banks. Security, advanced encryption and authentication protocols protect data from unauthorized access. Scalability, you can add large amounts of capacity without adding significant infrastructure. And compatibility with broadband, supported by broadband service providers such as DSL and cable. VPNs are commonly implemented as the following. So site-to-site VPN, so that's normally configured on the router, both maybe head office and branch office, and so they have that tunnel between them. And so the actual client machines never know that it's actually been VPN'd. While remote access is where a user will connect their host to a VPN server, and so there is a tunnel between their computer and the VPN server. For example, using HTTPS in a browser to connect to your bank. Alternatively, the user can run VPN client software on their host to connect to and authenticate with the destination device. So, Isp Connectivity Options. So there are different ways an organisation can connect to the ISP. The choice depends on the needs and budget of the organisation. So single homed basically means you've got one ISP, all on one link. provides no redundancy and is the least expensive option. Dual homed connects to the same ISP using 2 links, provides both redundancy and load balancing. However, the organisation loses interconnectivity if the ISP has problems. Multi-homed is where you have 2 different ISPs. This design provides increased redundancy and enables load balancing, but it can be expensive. And dual multi-homed, is the most resilient, and so the client connects with redundancy links to multiple ISPs, and so this topology provides the most redundancy possible. It is the most expensive as well. So you got multiple links to each ISP. So you got multiple ISPs, you got multiple links to the same ISP or just one link. Okay, broadband solutions. So comparing the ones that are available, each broadband solution has advantages and disadvantages. There are multiple broadband solutions available. A cost versus benefit analysis should be performed to determine the best solution. So cable bandwidth is shared by many users, therefore upstream data rates are often slow during high usage hours in areas with oversubscription. DSL, limited bandwidth that is distance sensitive, so how far away is the exchange. Upload rate is proportional lower compared to the download typically. Fiber to the home, this option requires fiber installation directly to the home, so that could get expensive. Cellular Mobile, well, this option coverage is often an issue, even within a small office or home office where broadband bandwidth is relatively limited. So municipal Wi-Fi, most municipalities don't have a mesh Wi-Fi network deployed. If it's available and in range, then it is a viable option. Satellite, this option is expensive and provides limited capacity per subscriber, typically used when no other option is available. Okay, that's it for the chapter pretty much, just a bit of a recap. So wide area network is required to connect beyond the boundary of a LAN. Private WAN is a connection that is dedicated to a single customer. Public WAN connection is typically provided by an ISP or telecommunications service provider using the internet. WANs are implemented using the following topologies, either point-to-point, hub and spoke, dual-homed, fully meshed, and partially meshed. A dual carrier connection provides redundancy and increases network availability. The organisation negotiates separate SLAs with the 2 different service providers. Site-to-site and remote access VPNs enable the company to use the internet to securely connect with employees and facilities around the world. Modern WAN standards are defined and managed by a number of recognised authorities, so TIA, EIA, ISO, and the IEEE. Layer 1 optical fiber protocol standards include SDH, SONET, and DWDM. Layer 2 protocols define how data will be encapsulated into a frame. Layer 2 protocols include broadband, wireless, Ethernet WAN, Mpls, PPP, or HDLC. Serial communication transmits bits sequentially over a single channel, in contrast to parallel, which simultaneously transmits several bits using multiple wires. 2 most common types of circuit switch technologies are PSTN and ISDN. Common types of packet switch technologies are Ethernet WAN and Mpls. There are 2 fiber optic optical fiber OSI layer 1 standards, SDH and SONET. And so they define how to transfer multiple data, voice, and video communications over optical fiber using lasers or LEDs over great distances. Circuit switch connections were provided by PSTN carriers. ISDN is a circuit switch technology that enables the PSTN local loop to carry digital signals. Packet switching segments data into packets that are routed over a shared network. Frame relay is a single layer 2 MBMA, so non-broadcast multiple access WAN technology used to interconnect enterprise LANs. ATM is capable of transferring voice, video, and data through private and public networks. It is built on cell-based architecture rather than a frame-based architecture. Modern WAN connectivity options include dedicated broadband, Ethernet WAN, and Mpls, along with various wide and wireless versions of internet-based broadband. Mpls is a high-performance service provider WAN routing technology to interconnect clients. It supports a variety of client access methods, be that Ethernet, DSL, cable, frame relay, and can encapsulate all types of protocols, including IPv4 and IPv6. Internet-based broadband connectivity is an alternative using to using dedicated WAN options, and so the most common ones are DSL, cable, and optical fiber, at least for the wired ones. And of course, when it comes to wireless, there is cellular 3, 4, or 5G, or satellite internet connections. DSL is a high-speed, always-on connection technology that uses existing twisted pair telephone lines to provide IP services to users. Distance is a problem. Cable technology is a high-speed, always-on connection technology that uses a cable company coaxial cable to provide IP services to users. Of course, you share it with all your neighbours. Newer developments in wireless technology include municipal Wi-Fi, cellular, satellite internet, and WiMAX. VPN tunnels are routed through the internet from the private network of the company to the remote site or employee host. Isp Connectivity Options include single-homed, dual-homed, multi-homed, and dual multi-homed. There is the logo, so that's the end of Chapter 7. So we'll be back with Chapter 8 with you in a very short time. Have a nice day. See you later.